Good afternoon, guys. How are you today? Hopefully you are feeling good and ready to move to new and more interesting material. Chapters 4, 5, and 6, like I said before, are all on formal logic. So we'll be doing formal logic now, logic which deals with the form rather than the content of the arguments. And this is actually like a foundational stuff for proper logic. Whereas stuff we covered in chapters 1, 2, and 3 applies to language and many other areas equally. This is what you may say the real logic, where we will be dealing with, first of all, categorical syllogisms. In Chapter 4, Categorical Propositions, which is kind of preparation for Chapter 5. And Chapter 5 will be able to actually figure out whether or not categorical propositions, categorical syllogisms are valid or whether they are invalid. Which is, remember, we mentioned briefly at the beginning that it's possible to do so, but you have to know a lot of different stuff in order to be able to do it. And then chapter 6 deals with propositional logic, which is kind of next step from that. Categorical propositions and categorical syllogisms, this is something which goes back all the way to Aristotle. It's been a staple of any, not only logic class, but any university course from back from medieval times. They started doing that somewhere like around 1,000 years ago, before even the first universities appeared. And then the first universities, when they were appearing in 11th, 12th century, they always started their curriculum with this Aristotelian logic. It was more complicated back then. Also, they did the entire thing in Latin. As you will see, some of the Latin terms and some of the Latin designations still remain with us today. For a very long time they had no idea what they needed for, what to do with all this stuff. Then they started using it with math. Math was one of the first fields of application. Why? Because in math you can use logic in order to write proofs. If you guys take higher level math classes, even starting from calculus 1, calculus 2, they already want you to understand, but you can do proofs for some of these things. They don't necessarily, depending on the professor, they probably don't ask you to write proofs, but they want you to understand proofs. But if you move further in mathematics, especially if you want to do stuff like engineering or major in mathematics, then you definitely will write a lot of proofs. Because beginning from like second year, almost everything starts revolving about proofs. Prove it. Show me the proof. And all of that is done with logic. And then after they have discovered that it can apply to mathematics, they also discovered that this is how computers work. The first computers were based on the rules of logic. And so if you know anything about computer languages, then you already know a little bit of logic, because any computer language is basically just rules of logic. And what we will do in the end, especially in chapter 6, is kind of like that type of stuff. Obviously it's not going to be as complicated as that. We'll just learn some basic rules and basic ideas, so if you ever take these classes in the future, you'll be ready. If not, well, that is something which you still should know, because it is kind of general knowledge which any well-educated person should have. And if you are aspiring to get in any kind of degree, you should definitely know that. Is it easy? Well, for some students it is, for others it's not. It really depends on how your brain works. Some people have natural ability to do that very well. Others struggle with it. It's not going to be very demanding, like I said, but the results are obviously different. Okay, so today it's just some of the basics we will need for categorical propositions. components, and then what is quality, quantity, and distribution, and we'll just barely touch on 4.3 existential import, because the material, there is actually not that much of material, but it's more important to get it down well and do the exercises and understand how it works. So let's take a look at these 4 categorical propositions. These are all categorical propositions, by the way. So reality TV stars hope for recognition, junk foods do not belong in school cafeterias, many of today's unemployed have given up finding work, not all romances have a happy ending. Can you see that they are categorical propositions? Do you see anything in common here? What is going on in terms of what they tell you? Well, yes, of course it may or may not be true, but that's what makes them propositions, right? Proposition is something which is always true or false. Otherwise it would not be a proposition. Question is not a proposition. Command is not a proposition. So this is all propositions based on people. I guess it does have to do something with people, except junk food do not belong in school cafeterias. It's not really that much with people as with food. The other 3 do include some types of people. Okay, so basically what is going on in all 3 of them is they relate 2 classes or 2 groups of things. Think about it. Reality TV stars hope for recognition tells you that all reality TV stars are kind of people who hope for recognition. So if you take people who hope for recognition, you do this one on the board. If you draw it like this, suppose this is all the people who hope for recognition. The reality TV stars will all be included here. This is your reality TV stars. They're all here. So there are some people who hope for recognition, and they are not reality TV stars. But if you are a reality TV star, you definitely are part of this bigger circle of people who hope for recognition. Right? This is the first one. The second one, which says junk foods do not belong in school cafeterias, just tells you that if this is your junk foods, and this is the foods which belong in school cafeterias, they don't overlap at all. They are completely separate. Now this third one, many of today's unemployed have given up on finding work. How do we do that? Well, if this is people who gave up on finding work, unemployed people would be included here. But how many of them? It says many. What is many? Well, we don't actually know what many is, but wouldn't it be fair to say there is at least one person? There is at least one person who is unemployed and is in here, people who gave up on finding work. So we would put it as an X. There has to be at least one. Maybe more, but at least one. And finally, not all romances have a happy ending. What does that mean? That actually means that there is at least one romance which does not have a happy ending, right? Not all of them. So at least one romance. So if this is the romances which have happy ending, there would be at least one romance here outside of that group. The one which doesn't. Maybe more, but at least one. And that is 4 types of categorical propositions. All 4 of them. Note that it actually lists all possible relations between 2 classes of things. One class can either be completely included in another one, or completely excluded, or partially included, or partially excluded. And this is all the possible variations. You can't have anything other than these 4. Okay, so this is specifically what we will be dealing with in chapter 4. What is a proposition? Again, just to remind you. Proposition is a sentence which is either true or false. We were saying statement is a sentence which is either true or false. Well, it is more or less the same. in reality there is a small difference between statement and proposition. You don't have to worry about it too much. Remember, proposition is something which is not in any language. Grass is green is a proposition that a particular plant called grass has a particular color which is green, and the person who speaks English will agree with that. But that same proposition in Russian again would be talking about exactly the same state of affairs, and the person who speaks Russian would also agree with that. And if somebody speaks both languages, he would understand both of them, and that would be equally applicable to French, German, Japanese, Chinese, ancient Greek, any language you take. So the language here doesn't matter, but it is a proposition which relates to a particular state of affairs, and if that state of affairs is true, then the proposition is true. And if it said grass is red, no matter which language you say it in, that would be false. So that's what proposition is. One thing about standard form. We will be using standard form categorical propositions. Now these four are not standard form. That's why it's so difficult to work with them, or to even figure out the fact that they are all categorical propositions. Once you put it in standard form, it becomes easier. In standard form, we will simplify all of them and turn them into something like this. They will always start with either all, no, or some. They will have what is known as copula, are or are not, and we will have two classes. Left one will be subject term, and the right one will be predicate term. So all ducks are animals, no humans are horses, some soldiers are cowards, some subatomic particles are electrons. This is all standard form categorical proposition which describe this exact same four relations. Okay, we can remember them like this, and this is kind of jumping ahead a little bit because some of this stuff comes up a little bit later in class, but I want to do it right now. So this is the same four relations for all four of them. First one would be all S are P, no S are P, some S are P, and finally some S are not P, which again, in terms of the circles, this one is all S is included in P. This one is S is here, P is here, they are completely separate. This one is, there's at least one S which is part of this P circle, and that one is, there is at least one S which is outside of this P circle. So this is the four relations. They also have letter names, they come up later, but let me tell you now. This one we call A, this one we call E, this one we call I, and this one we call O. A, E, I, and O. All S are P, no S are P, some S are P, some S are not P. And like I said, that actually is exhaustive list of all possible combinations two classes or two categories of things might have in reality. Either the one is completely included in another one, completely excluded, partially included, or partially excluded. So this is the first example we had. Reality TV stars hope for recognition. Now, note that if we want to put it in standard form, we will have to turn it into this all SRP. How would we do that? We would say all reality TV stars are people who hope for recognition. Junk foods do not belong in school cafeterias. Again, that describes these relations. This is not standard form. How do we turn it into standard form? We would say no junk foods are foods that belong in school cafeterias. Note that I'm adding some words there to make it standard form. Many of today's unemployed have given up on finding work. Again, that's not a standard form, but this is this relation. How do we turn it into standard form? We would have to say some unemployed people are people who give up on finding work. And finally, not all romances have a happy ending. Not a standard form, but this is the relation. So we can turn it into standard form by saying some romances are not romances that have a happy ending. This is the four relations again, kind of listed like this. All SRP, no SRP, some SRP, and some SNP. This is from the book, but it's easier to remember them in this kind of square way, and we will work with it like this in the future. By the way, do get paper or some sort of writing equipment. These days doesn't have to be paper, right? You can do the writing on iPad or whatever other stuff, but make sure you actually do, because during the class you will have to take notes about that. It's not good enough to listen to it, especially if you want extra credit. You will need something to look at, and I wouldn't use the book for that. I would actually have notes, something like this, because that stuff's on the board now. It's not going to be on the board all the time, especially given that this board is fairly small. When in class I have like rather large board material, I can keep some stuff there and write some other stuff. Here I will have to erase it, otherwise there's just no space. So for this reason, you may want to keep it on your notes somewhere handy, and also to do exercises. So this is the components of a categorical proposition. Each categorical proposition in standard form will have quantifier, which is either all, no, or some, followed by the subject term, whatever it may be, followed by the copula, which is either are or are not, followed by the predicate term, again whatever that may be. Again, note, we're talking about standard form categorical proposition, so for most exercises it's already standard form. You don't have to do anything to it, but to understand the difference is not all of them are in standard form. Standard form will always have this very strict, following this very strict rules, that it'll start with all, no, or some, and then have two terms in the copula. Here's an example. All members of the American Medical Association are people holding degrees from recognized academic institutions. Now this is standard form. It has quantifier, all, it has copula, are, and it has two terms separated by this copula. Members of American Medical Association would be your subject term. People holding degrees from recognized academic institutions would be your predicate terms. Note that the form can also be expressed briefly like this: all SRP. S stands for subject term, P for predicate term. What is the term? For standard form categorical proposition, it matters that we have two clear terms and they have to follow these rules. It is similar to how we looked at terms before. There's a little bit of a different style. Remember, we were doing exercises about terms. What did we say? Term was something which can serve as a subject of a statement. It's more or less like this again. You can have combination of words, not a single word. Something like people who write best-selling novels would be a term. Famous authors would also be a term. However, we have a couple more requirements. The first requirement is that it cannot be an individual, because we're talking about classes. That's why I was changing them. Some philosopher is Socrates. Note that this is, of course, a categorical proposition. However, it's not standard form, because Socrates is just one person. It is not a class. If you want it in standard form, you have to turn that part into, first of all, a class, and you have to replace is with one of the copulas, which is either are or are not. You can't have anything other than that. How do you do that? Well, very simply, you can replace Socrates with a group of people called people identical with Socrates, for example. Note that that group will only have one member, which is Socrates. However, then you will have a standard form categorical proposition. Some philosophers are people identical with Socrates. Note now you are using are and you have a group. May seem silly for people unfamiliar with logic, but it is important because standard form does have these requirements. It has to be two classes and one person is not a class. So even though it's silly to say people identical with Socrates, but it's not silly for logical purposes. And another thing, well, again, we actually did say that before, you can't have adjectives. Now this is again a categorical proposition. All paintings are beautiful. However, it's not standard form. In order for it to be standard form, beautiful isn't good enough. Beautiful is not a class of things. What would you do? Well, you can actually say beautiful things. Now that would be a class. So then you will have all paintings are beautiful things. That is now a standard form, which is why I was changing the wording before when we were going over this first four, because in order for them to be really nice and neat standard form categorical propositions, you have to follow these rules. Okay, let's do a little exercise now. Usually we used to do it on the board. In your case, guys, I don't think we can do it on the board because I can't have you come here and do it on the board for me. But do it first of all for yourself on paper. This is how it's supposed to go. You have to identify quantifier, subject term, copula, and predicate term. So this is how I would do it. Let me just do it on the board for you. See, like a little table here. No stressful jobs are occupations conducive to a healthy lifestyle. What's your quantifier? No. What's your subject term? Stressful jobs. What's your copula? Are. And what is your predicate term? Occupations conducive to a healthy lifestyle. Okay. You may think it's a little bit of a pain to write them down like this, but this is what you really should do for yourself on some sort of a paper for all three of them, because that will help you to understand the differences and understand if you're doing something wrong. So this is the two remaining ones. Try to do that. Now for extra credit, how should we do the extra credit? Let's do it the following way. I don't want you to write everything, but give me 3 predicate terms. Predicate terms for all 3 of them divided by the comma. First predicate term, comma, second predicate term, comma, the third predicate term, comma. If you get it right, you get extra credit. Following the rules is probably the most important thing in formal logic. In that sense, it is like math. You follow the rules, you will always get the correct result. If you don't follow the rules, you will make mistakes. Okay, so just so you finally got it correctly. Note that your first option was completely wrong. Prone to failure. Who is prone to failure? You have jumped to a different R. This is not the R which is the copula. This R is the copula. Mechanisms that are prone to failure. Note again that prone to failure would not be a class of things. It would have to be mechanisms or things or whatever else prone to failure rather than just prone to failure. Prone to failure is not a term. Okay. What is that, Christopher? Where is it? What is going on? Oil-based paints? Products contribute? Oh, you just repeated number 3 in its entirety? Okay, you confused me. No, I was asking for the predicate terms only. Well, in any case, Jess got the extra credit here. Oh, your first extra credit, huh? Okay. Right, we will do more extra credit. But note that, like I said, in formal logic, you have to be very methodical. So this is the predicate terms. Occupations conducive to a healthy lifestyle. Products that contribute significantly to photochemical smog, and mechanisms that are prone to failure. I didn't ask you to write everything down, just the predicate terms, because it's just no time and I don't want you to write like a mini essay here. But the point is, if we were in class, I would want you to do it on the board like this. And right now it's obviously not that easy. Okay, so we're done with 4.1. 4.2 gives a few other things to you need to understand. First one is quality, second one is quantity, and third one is distribution. Again, we have to go back to the same picture we had before, because this is exactly how I want you guys to remember it. And you certainly should get this part really well. So we have, once again, 4 possible categorical propositions: A, E, I, and O. And your A would be all S RP. Your E would be no S RP. Your I would be some S RP, and your O would be some S R not P. So once again, quality, we have 2 qualities, affirmative and negative, depending on whether it affirms or denies class membership. So the 2 affirmative ones are these 2. And the 2 negative are these 2. And it is very easy to understand why these 2 have words no and not. Words no and not are negative words, right? So that's why these 2 you can immediately see are negative. And these 2 are affirmative. Okay. This is quality. How about quantity? What's the deal with quantity? Quantity works in a similar way, and it can be either universal or particular, depending on whether a statement makes a claim about every member or just some members of the class denoted by the subject term. So again, going back here, now we have to do it this way. So these 2 are universal, and these 2 are particular. So you see these 2 go this way, and these 2 go that way, which is why it's so nice to put them as a square. These 2 universal, these two particular, and you can distinguish the particular one because they start with the word some. So they don't make a claim about every member, only about some members of the subject term, which is why they are particular. Whereas universal make a claim about all of them either inside or outside of the other class. Okay, designation, well, I already told you this, guys. So designation is A, E, I, and O. Why these letters? Why not A, B, C, and D or something? Well, that actually goes back to the medieval days, and the answer is rather simple here. They used Latin language, which conveniently enough is very similar to English language, and in Latin, affirmative is affirmo, and negative is nego. So that's your explanation. They just took A and I, E and O from affirmo and nego. We are kind of lucky with English language because it makes perfect sense in English. A lot of English words do come from Latin, and therefore they're very similar. Doesn't work as well in Russian or Japanese or some of the other languages, but works perfectly well in English, French, or Spanish. Spanish probably even better. So that is why. But we still keep it this way. We do not use Latin language that much now, but we keep the designation as A, E, I, and O. So again, that's why affirmo and nego. Distribution. What is a distribution? Well, unlike quantity and quality, which are attributes of the whole propositions, distribution is an attribute of terms of proposition. A term is said to be distributed if the proposition makes an assertion about every member of the class denoted by the term. So if proposition makes a certain assertion about every member of the class, then it's said to be distributed. If it does not, then it is undistributed, the class. Either distributed or undistributed. Okay, so let's take a look. Let's see if you can figure it out. All S are P. Does this proposition make a claim about all members of S class? Yes. It says that all of them are included in P class. Does it make any kind of statement about all members of P class? Any assertion about them? No, because some of them are identical with S, some of them are not, so who knows? For this reason we say S is distributed and P is not. So for A type, S is distributed and P is not. Now let's look at the E propositions. No S are P. Does it make any claim about every member of S class? Does it? Now think about it. In this case, what does it say? No S or P. Does it make any claim about all members of S class? Yes. Each and every one of them. It says that each and every one of them is not P. How about P? Does it make any claim about all and every member of P class? Again, yes. It says that they all are different from S. So actually both of them are distributed here. In E propositions, both S and P are distributed. Now, maybe a little bit more difficult with the particular one. So let's see. Some S are P. Does it make a claim about every member of S class? No, because obviously there could be S's which are not P or which are also P. Who knows? How about P? Does it make a claim about every member of P class? Again, no. No, it does not, Christopher. It doesn't make about every one of them, because some of them are identical with S, some of them are not, so that does not make any claim about all of them. And for this reason, none of them is distributed. For I, none of them is distributed. And finally, how about O? Some S are not P. Does it make any claim about every member of S class? No. Does it make any claim about every member of P class? Well, that one may be a little tricky. It does. It makes a claim that every member of P class is different from that one S. So in relation to not the entire class of S, but this particular one S, it does make the claim about every single one of them. And it says they are all different from that S. None of them is identical with this S. So actually, P is distributed here. Okay. So this is how they go. A proposition S is distributed, E proposition both, I neither, O just P. There's a mnemonics to remember this stuff. Either way, you can universal distribute subjects, negative distribute predicates, unprepared students never pass. I don't want you to remember it, actually. I want you to understand it, but you don't have to remember it, because that's not something I will demand on the exam or anything like this, so you don't need to go over the mnemonics. But it helps to understand them, especially for some of the stuff we'll be doing later. So this is distribution. This is a nice little summary. All the prepositions, letter names, quantity, quality, distribution for all of them. It's in the book. Okay, just a little bit to start on 4.3, existential import. This is something students sometimes struggle with, so it makes sense to do it kind of twice. We will repeat it again at the beginning on 4.3 briefly, but I will talk a little bit more detailed right now. What is existential import? Take a look at this proposition. All Tom Cruise's movies are hits. Does this imply to you that there are indeed some movies made by Tom Cruise? That Tom Cruise made some movies, that they actually exist? If somebody tells you this, suppose you don't even know who Tom Cruise is. Suppose somebody tells you all John Jones's movies are hits. Would you take it to mean that there are at least some John Jones's movies in existence? Yes. So that's what we call existential import. We say that that proposition has existential import. Now, take a look at this one though. All unicorns are one-horned animals. That proposition, if somebody tells you this, would you take it to mean that there are unicorns? No. Sometimes students tempted to say yes, but if you think about it, the correct answer is no, because just because somebody tells you this, you would take it to mean that they're talking about imaginary creature and imaginary features that creature is supposed to have according to the legend. But you will not take it as they actually exist. That would be crazy, right? So for this reason, we say it does not have existential import. That's what existential import is. Now, there's a question we have in logic. Should universal propositions be interpreted as implying that things talked about actually exist or not? So when you say about anything that it's either all SRP or no SRP, are you implying anything about the existence of them? That's a good question, yeah. That is why we are confused about whether or not to give them existential import, because you actually have to know whether they exist. And that is, first of all, you have to go outside logic, you have to go into epistemology and figure out how do you determine that. And sometimes it may be impossible to determine. Suppose I tell you all the students who failed the exam will fail the class. Well, do you know if anybody failed the exam? Unless I tell you so, you may not even know if there are such students. So whether or not it has existential import may be questionable. So that created some problems, and we have two approaches to this subject. First approach is Aristotelian. Aristotelian standpoint, that's how Aristotle looked at it 2,300 something years ago. He would say that A and E proposition only universal. Note that we're only talking about the universal propositions. He would say that universal propositions A and E only have existential import when we talk about things which actually exist, and they do not have existential import when we talk about things which do not exist. So he would say, when you say all pheasants are birds, you imply the existence of pheasants. When you say no pine trees are maples, you imply the existence of pine trees. However, when you say all satyrs are vile creatures, you do not imply the existence of satyrs. So it depends on whether or not your S-class actually exists. And just like Sarah, you rightfully pointed out, that opens the can of worms about how do we know. So for that reason, we have a Boolean standpoint. George Boole, in 19th century, 200 years after Aristotle, decided to simplify that and to say, how about we just never imply the existence? How about we just, whenever we have universal proposition, we'll by default say it does not imply the existence of anything. So when we say all trucks are vehicles, we do not imply the existence of trucks. When we say no roses are daisies, we do not imply the existence of roses. And equally, when we say all werewolves are monsters, we do not imply the existence of werewolves. So just, simple approach. Never imply any existence. It may seem like a great solution. Unfortunately, as we will see later, it robs us of some of the very important relations which we will not have if we take this approach. And by the way, just to explain to you a little bit more in terms of this picture, what's going on here. What's going on is this. Remember, we are drawing circles, right? So in this case, we are going with bigger circle for P, smaller circle for S. In this case, circle for S, circle for P. In these two cases, we're going with circle for P and little x for S. And in this case, we're going with circle for P and little x for S. Now, here's the deal. When you draw in a circle, you are not implying the existence. Circle just means if there is something there, it will be in that area. How would you imply existence? You would have to put an x inside that circle. Now, once you put an x there, you are saying there is one thing there. So without that, there's no existence implied. That's why we have no disagreement about particular. Why? Because we have an x. So we do say that for both particular type of propositions, some s are P and some s are not P, we always imply the existence. So when we put an x, that means there's something there. There's at least one thing there. And that is implication of existence. So once again, the disagreement only applies to universal ones. So just to sum it up, we call it, Aristotelian standpoint is open to existence. Meaning it could be or it could not be. It's open. And it depends on whether or not that thing actually exists. Boolean is closed to existence. Why? Because it always says that universal do not imply any existence, and that's it, period. But for particular ones, I and O, they always, from both standpoints, they always imply the existence. So when we say some cats are animals, we are implying there is at least one cat. When we say some fish are not mammals, we imply there is at least one fish. And just in case you're, yeah, exactly. That may seem strange, but nonetheless, if we are saying some gods are vile creatures, we are implying there is at least one god. That is true. Some unicorns are in my kitchen implies that there is at least one unicorn in my kitchen. Now, that would make it false, right? The proposition would be false. Nonetheless, we are implying the existence here. The truth and falsity is something external to this implication. So we can find out whether it's true or false already after the fact. Just like with the movies, right? Whether if you're saying Tom Cruise's movies are hits, that may be true or false. You are implying the existence of them, but it may still be false.